So, 3.6 quadratic modeling. What we're going to do is look at this problem and be able to determine the equation from this graph. That is, we need to look at the zeros and we need to look at another point. Once we use the zeros and another point, we can find the equation of this parabola. Now, once we find the equation, don't forget we need to express the answer in a standard form. So again, we're going to determine the equation of the parabola, not part B but just A, by determining the zeros of the function, writing the function in factored form, determining the value of A using a point on the curve, and expressing your answer in standard form. So we're going to do it step by step. Ready? Here we go. We take the zeros, the roots, r equals -5 and s equals 3, and we're going to sub this information as well as the point 0, -30 into the equation in factored form, which is y equals a x minus r times x minus s. So again, we're going to sub r equals -5, s equals 3, and 0, -30 for x and y into this equation. So now we're going to plug it in. What's y, folks? Well, y is -30 equals a times x, which is 0, minus -5 times x, which is 0, minus s, which is 3, and we're going to plug this all in. So we have -30 is equal to a times 5 times -3, which is -30 equals -15a. We divide both sides by -15, and we find out that a is equal to 2. So, because a is equal to 2, we rewrite the equation y equals 2 times x minus -5, which means x plus 5, and x minus 3. Now, this equation is in factored form. We need to write this in standard form. So that means expanded form. Y equals 2, x squared minus 3x plus 5x minus 15. Y equals 2x squared plus 4x minus 30. And you may not understand where that came from, so what I did is I showed you the step that I skipped. It's okay to skip this step, folks, and you will get the full mark. So let's look at that back for a second, just so that we know what's happening here. And we're just going to move back a little bit to find out what we're looking at. 1 second. All right, here it is again, folks. Again, so we collected the like terms here and then multiplied the 2 into each piece, and that gave us this value. This is the equation of this parabola. All right, moving on to the next lesson. So this is the next example. Determine the type of function. So here we have some values here, and we're going to determine the type of function. To determine the type of function, we notice that first, these x values are not in order. So let's put them in order. X starting with 0, 0, 1 and 0.45, 2 and 0.8, 3 and 1.05, 4 and 1.2, 5 and 1.25, 6 and 1.2, 7 and 1.05, and 8 and 0.3. Once we do that, we will check through. We're going to check that the x's are going up in a pattern. So we're looking at delta x. Delta x means how are the x's changing? They're going up by 1 each and every single time. We have to check all of these values. For example, if these values were not the same, what would you write? Well, hopefully you're thinking that you would write that you're unable to determine. Because if these x's aren't going in a pattern, it doesn't mean it's not linear or not quadratic. What it means is we can't determine from the table. But lucky for us, all of these x's go in a pattern. So now we're going to move to the other side. we need to get the y values. How do we find what's happening with the y's? Well, we do delta y is plus 0.45 plus 0.35 plus 0.25 plus 0.15 plus 0.05, and then next is we're going to have plus, oh wait, no, careful, we're going to have minus 0.05, and next we're going to have minus 0.15, and finally we're going to have minus 0.25. So we can see that it definitely isn't linear. So now we're going to look at delta y. And we're going to do that in a different color, and we're going to look at the delta y. Delta, delta y. Delta, delta y says, okay, well these numbers are going down 0.1. These numbers are going down 0.1. The next numbers are going down 0.1. And again, down 0.1. And again, down 0.1. And again, down 0.1. And finally, down 0.1. So we're going down 0.1 all the way down. So what kind of function does this represent? Well, hopefully you're thinking it's quadratic. And you'd be right if you're thinking quadratic. Because the delta y values are all the same, we can determine that this function is this table represents a quadratic function. So therefore, the table represents a quadratic function. And why does it represent a quadratic function? Hopefully you're thinking, okay, well delta x are the same and delta y are the same. So all the delta x values are the same and the delta y values are the same. All right, folks. Well, that's the end of the lesson. Have a numerical day. Take care.